Alright, today we are going to review some more factoring and we are going to do a quiz review for our quiz. Alright, how to factor. Number one thing when you factor is check for a GCF no matter what. That's the first step. Now, if you have two terms, you check to see if you have the difference of two squares. And we know that we need subtraction and we need two perfect squares for that. For number 3, the next thing we look for is for regular factoring. And if we are doing regular, that is when we've got 1x squared plus bx plus c. And our last option, even though it's amazingly awesome, is Batman. And Batman is when you have a coefficient with that x squared. Now the GCF you always do first, no matter what. Sometimes there's GCF, sometimes there's not. If you have two terms, you're looking for the difference of two squares. If you have three terms, you look for regular or for Batman. So kind of a guidelines on where to go. Alright, get ready because we are going to move quickly through your quiz review. We start with number 1. I see an equal sign with number 1. Because I see an equal sign, I know not only am I going to factor, I'm going to solve too. So I'm looking for pieces to multiply to the outside, add to the middle. I break up my factors. I got my x, I got my x. Multiply to a negative, add to a negative. That means I've got one positive, one negative, where the negative is larger, and that negative is a 6, and the positive is a 1. Now, because I've got that equals 0, I'm going to use ZPP. X plus 1 equals 0, x minus 6 equals 0, and we've got a solution when x is, a negative 1, and we've got x is equal to a positive 6. We move over on to number 2. There's no equal sign, so the only thing I'm going to do is factor. I multiply to the outside, I add to the middle, I ponder, I think, okay, what two numbers multiply to a negative 10 and add to a negative 7? I break it up, x, x. I know if I'm multiplying to a negative and adding to a negative, I know I have one positive, one negative. Well, if I have a 10, it's 10 times negative 1, that's a negative 10. 10 minus 1, that's a 9. That's not even close. So the only other two numbers that multiply to 10 are 5 and 2. So let's try 5 and a negative 2. Negative 10, 5 minus 2 is 3. Still not even close to the same number. Sometimes you'll get the same number, wrong sign, then you just switch ones, go with the positive, which one is negative. But we can't even get the right number. This one is prime or not factorable. I can't factor it. I'm done. Number 3, we look here and we have an equal sign. We do not have an equal 0, but we do have an equal sign. Because I have an equal sign, I know I'm going to solve. But I need to make it an equal 0. So we move that 10 on over. 3x squared plus 7x plus 10 is equal to 0. So now I start my factoring process. GCF. No GCF. I've got three terms. My first term is not a 1, so I've got Batman. 3 times 10 gives us 30. Pull down that 3x squared. Pull down that 10. And we're looking for two numbers that multiply to 30, add to 17. That is a 15 and a 2. Notice how you have x's with the middle terms. You will have Batman on your assessments, on your quizzes and tests. So don't just say, oh, Batman has the most work, so it's worth the most amount of points. So know how to do it. Now we factor by grouping. Group our first 2, group our second 2. Our GCF here is a 3x. We're left with x plus 5. Our GCF here is a 2. We're left with x plus 5. And again, we double check. Make sure that the piece in the parentheses are exactly the same. If they're not, we've got a problem. We take the two GCFs together. There's factor number 1. We take our second two pieces together. There's factor number 2. Now I had bad form here. We have to carry down that equals 0 each step. So I've got 3x plus 2 equals 0. Move the 2 over, it becomes negative. Divide by 3. And we've got x is equal to a negative 2/3 as one of our solutions. Then we've got our x plus 5 equals 0, and x is equal to a negative 5. So we have either a negative 2/3 or a negative 5. both of those numbers will give me a value of 0 when I plug it in. So I've got two different values of x that are going to satisfy my equation. Number 4, I look right off the bat, no equal sign, no solving. So all I'm going to do is factor. First step of factoring, GCF, I can pull out a 2. And once I pull out that 2, I notice that I have the 1x squared. So this is just going to be regular factoring. Multiply to the outside, add to the middle. So I set up my pieces. I have a sum and a product that are both positive. That means both my numbers are positive. Two numbers that multiply to 40 and add to 13. Think, think, think. 8 and 5. 8 times 5 is 40. 8 plus 5 is 13. We're not solving, so we're going to stop there. You will lose points if you keep going. So you've got to know the difference of when you should factor and stop or factor and solve. Number 5. We look, we've got an equal 0, we're solving. GCF is our first step. Make sure when you're pulling out the GCF, you pull out the entire GCF. Here, yes, they all share a factor of 5, but they also share an x. So I've got to pull a 5x out of that. I pull out the 5, pull out one of my x's, I've got x squared. Pull out the 5, pull out one of my x's, I've got 1x. I pull out the 5, I've got a negative 2. I don't have any x's left. Once you pull out that GCF, we still have a trinomial in the inside. So I'm still going to factor that. And it has a positive 1, so I'm going to use my regular factoring. We keep the GCF on the outside, we don't lose it. So I'm looking for two numbers that multiply to a negative 2 and add to a positive 1. If I multiply into a negative, I know I've got one positive, one negative. Since my sum is positive, I know that the larger number is positive. And in this case, it's a positive 2 and a negative 1. Now that equals 0, I've got to start solving. 5x equals 0, x plus 2 equals 0, x minus 1 equals 0. We divide by 5, and we've got x is equal to 0. We subtract 2, and we've got x is equal to a negative 2. We add 1, and we've got x is equal to a positive 1. Now you want to be careful here. We do have 3 solutions, and we had a GCF of a 5x. When we divide by 5, we do have a solution at 0. Let's just say for a second that my GCF here wasn't an x, it was just 5. So this was just a 5. This, and I had 5 equals 0. If there's no variable, there's no solution. In order to solve for x, there actually has to be an x there. So don't get fooled. You will have a solution of 0 when your GCF has a variable in it, because we can solve for 0 for x. If there's no variable, there's nothing to solve for. Don't get tricked there. Number 6. No equal sign, no solving. First step of factoring, GCF. We look, GCF of a 2. 4x squared minus 9. Now I've got two terms. I'm going to check for difference of two squares. I've got subtraction, good, and I've got two perfect squares. Take the square root of the first piece, which is 2x. We know that to get that middle term to cancel is to have 1 plus 1 minus. Square root of 9 is 3. Alright, we've got two more factoring problems. Crazy stuff going on, which means GCF is the only thing we do. 12, 6, 2, they share a 2. 2 A's, 1A, 1A. The most I can take out without having a problem would be 1. If I tried taking out more than 1, I wouldn't have enough in my second piece. 1B, 3 B's, 1B. Same reason, I can only pull out 1B. 5 C's, 8 C's, 3 C's. The most I can pull out is 3. If I try pulling out more than 3, my last piece is going to have a problem. So I pull out the lowest number out of all 3 pieces. 12 divided by 2, 6. I've got 2 A's, I took 1 away, I've got 1 left. I took out the only B, so there's no B's. 5 minus 3, I've got 2 C's left. Pull down that subtraction, 6 divided by 2 is 3. I pulled out the only A. I have 3 B's, I took 1 away, so I've got 2 B's left. 8, I take 3 away, I've got 5c's. Bring down that plus. 2 divided by 2 is 1. A, I took out the only A. I took out the only B. And I took out all 3 c's. So that is a plus 1. Do not forget that plus 1. Remember, 3 pieces here, I have to have 3 pieces still on the inside. Number 8, GCF. And the largest common factor is a 3. 2 terms, if I only have 2 terms, it's either difference of 2 squares or nothing. So I look, difference, good. I've got my subtraction. 4x squared, perfect square, good. 3, not so much. That's not a perfect square, so I'm done with factoring there. Go ahead and flip that sheet on over to the back side. And we want to write the equation of the function in standard form. If we have this in standard form, we are going to FOIL. And we're going to FOIL that first to get x squared plus 2x plus 1. Then the next step of order of operations is to distribute that 3. And then combine our like terms. So we've got y equals 3x squared plus 6x minus 2. Write the equation in vertex form. So vertex form, y equals a times x minus h, quantity squared plus k. And we have a vertex, which is at h, k. We've got a point at x, y. We plug all that stuff in. So our y is 3. We're trying to find a. We have our x from our point is 4. Our h is 2. Our k is negative 1. Simplify order of operations. So we've got 4 minus 2 is 2 squared minus 1. 2 squared is 4, so we've got 4a minus 1. Move that 1 over. And we find that a is 1. Remember, when you write your equation, you should only have an x and a y. So we've got y equals, our a value we know now is, which is 1. X minus, now we've got our vertex. The x coordinate is h, which is 2. So x minus 2, quantity squared, plus your k, and your k is a negative 1, so that's minus 1. Number 10, write the equation in intercept form given the x-intercepts of a negative 10 and a negative 8. So intercept form is y equals a times x minus p and x minus q, where p and q are those intercepts. So you've got a point, your x and your y. You've got intercepts, which are p and q. So again, we plug all of our knowns in. Oops. Our y is a negative 15 from our point. We're trying to find that a. The x is a negative 7 from the point, minus one of your intercepts, minus a negative gives us a positive 10. We have that x again, so we use negative 7 again. Minus our q, our other intercept, minus a negative is a positive. So negative 7 plus 10 gives us 3. Negative 7 plus 8 is 1. Negative 15 is equal to 3a. Divide by 3, and we get a is a negative 5. Just like the last one, we only have x's and y's in the answer. So we've got y equals, we found that the a value was 5, that's what we just did. X minus your intercept minus a negative 10 gives you x plus 10. X minus q minus a negative 8 means it's going to be x plus 8. Alright, now we are going to move on to some graphing problems. So if you do not have your calculator out, go ahead and press pause and get your calculator out. Okay, you can see that I have entered in my equation into y1. Remember, there's your y equals button. We're going to look at the orientation. When I look at the orientation of my graph, I know that I'm going to look at the a value. And we have a is a negative 2. Because it's negative, our graph is going to be going down. And because the a is greater than 1, the shape of that parabola is going to be a narrow shape. When we look at the vertex, unfortunately our equation is not in vertex form, so we can't just get it from looking at it. So what we want to do is we want to go ahead and graph this. We normally start off in 10 by 10 window, but I can see that my graph is going way off, so I want to change the window. I need to move up, and up is the y-axis, and I want to go higher, so I'm going to change my y-max. For now, it's just kind of guesstimating. I'm going to change it to 20 and hope that that's going to fix it. Alright, so let's see how that does. And still not far enough, so we're going to go back to our window again. We're just going to keep on going until we can get it big enough. And so I'm just going to change that to a 30, and that should do it. Alright, if we want to find the vertex, we want to find that highest point there. So we go to second trace. And the highest point for the vertex, we always use the min or max. Think about what you're looking for and which word is going to match what you're looking for. We want the highest point, so we want the maximum. It's telling you to go left of the vertex. I am left of the vertex. Scroll over to the right. Make sure that you pass over that hump. And then it's going to ask you to guess, so we go back towards the middle. And remember, we got to be smarter than the calculator. That's at 1.5 and 24.5 will be your vertex. Now we want our axis symmetry, which is going to cut that parabola in half, which is a vertical line, so we want x equals, and it's always going to go through that vertex, so it's whatever that x coordinate is. Now our y-intercept, if we want our y-intercept, we know that our x is at 0. If we want our x-intercept, we know it's when y is 0. To find the y-intercept, when x is 0, we can do the value, second trace, 1, 0. Remember, plugging 0 in for x. Yes, or you can just go to the equation that you have, plug 0 in there, that's gone. Plug 0 in there, that's gone. Because anything times 0 is 0, and that'll give us 20. And when we go to our calculator, we see that we get the exact same answer that we just did by hand. The x-intercept is not as easy because I'm going to plug 0 in for y. I could try to see if this factors. Sometimes it factors into integers and we're good, and sometimes it doesn't. That's why we have the y equals 0 and y2. So we go to second trace. We want to find the intersection point between our graph and our horizontal line. So if we sketch our graph here real quick, we see, let's go ahead and look at it. There's our parabola. If we want our x-intercept, we're looking for where that parabola and that horizontal line at 0 are going to meet. So here would be one x-intercept, here would be the other x-intercept. So we want to find the intersection point. First curve enter, second curve enter, and you'll see that the y's change in the corner. And it gives us that our first one is at -2, 0. We do the same thing, second trace, number 5. First curve, yes. Second curve, yes. Now you've got to make sure that you scroll over, and you have to hit enter a third time. You want that word to change from guess. When you hit enter, it changes to intersection, and that's at 5, 0. So we fill our information in here. Make sure that your graph is completely labeled. So we've got to fill in our vertex of 1.5, 24.5. We have our y-intercept here at 0, 20. You can see that my sketch is not exactly accurate there, which is fine. Sketching is sketching. Just make sure that it's relatively close. And then we've got our equation of the x-axis of symmetry, which is at x equals 1.5. Alright, next one, and our last one. This is our application word problem. Tara and her family are on vacation in New York, and they decide to visit the Soldiers and Sailors Ark in Buffalo. The arc can be represented by our given equation, where x and y are measured in feet. How wide is the base of the arc? How tall is the arc? So the first thing you want to do is get that into your calculator and see if you can get your window to work for you. So go ahead and press pause and see if you can get that. Alright, so I entered my equation in, and I see that I've got my -1/10, x plus 40, x minus 40. And when I graphed, I had always change back to a standard window, so zoom 6. I don't see anything at all. But we are lucky in the fact that our equation is in intercept form. So before I even go to my calculator, I know that I'm going to have an x-intercept way over here at a negative 40, 0. And I'm going to have an x or y-intercept. I'm going to change my... Alright, so what I'm going to do before I even go to my calculator is I have a general idea of what this is going to look like. I know that I'm going to have an x-intercept over here at a negative 40, 0. And I'm going to have an x-intercept over here at a positive 40, 0. That's going to help me find my graph in my calculator. So when I go to my window, this is on the x-axis, so I know that my x-min is got to be smaller than negative 40, so I'm going to go to a negative 50. I know that my x-max has got to be larger than 40, so I'm going to go to a positive 40. I know this isn't going to change everything, but at least now I'll be able to get something on my graph. Alright. Did we plug those in right? Oh, I went to 40 instead of 50. Okay. Either way, we see where our lines are going to cross, and I know that I'm going to have to move way up here. I'm going to move up more than by tens this time because I see that I'm not even close. I'm going to first start by jumping up to 50 since my other ones are 50. And it looks like we're still not even halfway there. So I'm going to jump way up to 200. So you're just going to kind of keep on tweaking and playing around with your graph until you can see the whole thing. And finally, I can see that my graph has a top and a bottom. I can see all my important information. I want to find that vertex. That's the highest point. So we're going to do the max. We're going to scroll, make sure that we go left of it. Make sure you go far enough. And then we go right. And again, we want to make sure that we pass over that hump. And then go back towards the middle. And this is a great example to come up. If you see negative 4.877 e to the negative 6 power, anytime you see e, that's scientific notation saying move your decimals 6 spots to the left. So that's really negative 0.00000487, which is an extremely long or small number. Anytime you see e to the negative number, that means 0. So that's at 0, 160. We want to decide how wide the base of the arc is and how tall it is. Well, if I'm looking to see how wide it is, that is talking about the x's. So from here to here, I have to go 40 to get to 0, and then I have to go 40 more to get to the other end. So it is going to be 80 feet wide. Then if I want to know how tall the arc is, I want to see how high up it goes. And we know that this is representing the ground. So from the ground up, well, hopefully you know it's not going to be 0. But the x-axis go left and right. The y-coordinates are talking about your vertical change. So we know that it's going to be 160 feet tall. All right, and that is it for your review for today.